Hello students, welcome. Previously, lesson 38, form 3, topic 2, we have started redox titration and we have done the first two aims of redox titration. So today, lesson 39, we are going to proceed to the third aim of redox titration, which is determining the percentage purity. Example. So here we have 53.0 gram of sodium nitrite was made up to 600 centimeter cube using distilled water. Full stop. 30 centimeter cube of the solution required to be oxidized by 29.5 centimeter cube of 0.36 molar potassium manganate 7 in acidic medium. So we are asked to determine the percentage purity of sodium nitrite. So we are given the relative atomic mass of sodium to be 23, the one for nitrogen to be 14, and the relative atomic mass of oxygen to be 16. Here we are having the ionic equation for the reaction between potassium manganate 7 and also sodium nitrite. So here we have to start with looking for the number of moles of potassium manganate 7. Remember, the formula for calculating moles is just molarity times 1000, molarity times volume used of 1000. Moles of potassium manganate 7 will be equal to molarity, which is 0.36 multiplied by the volume, which is 29.5, and divided by 1000. So here we are going to get 0.01062 moles of potassium manganate 7 solution. We said number of moles is calculated by taking molarity multiplied by volume, then divided by 1000. Thereafter, we have to get the number of moles of sodium nitrite using ionic equation or using the equation given. We can get by the use of mole ratio the number of moles of sodium nitrite. So if we check potassium manganate 7 ratio sodium nitrite, so the mole ratio that we have here is 2 in the side of potassium manganate 7 ratio 5 in the side of sodium nitrite. Sodium nitrite. That's how we are going to do. So we know the number of moles of potassium manganate 7 because we have calculated now as 0.01062. Then we can ask ourselves what about the one for sodium nitrite. So we cross multiply. Here we are going to say 0.01062 multiplied by 5, then divided by 2. So what are we going to get? What we are going to get here will be 0.02655 moles of sodium nitrite solution. That's what we are going to get. So the next step, let's know this number of moles has a volume of 30 centimeter cube. We are told 30 centimeter cube of the solution required to be oxidized by this potassium manganate 7 solution. So we can ask ourselves, what about the 600 centimeter cube that was 53 grams of sodium nitrate was dissolved? So we are going to say if 30 centimeter cube of sodium nitrite can have number of moles as 0.02655 moles. So we can say, what about 600 centimeter cube of sodium nitrite? What number of moles can it give us? So we are going to multiply 600 multiplied by 0.02655, then divided by 30. So here we are going to get a number of moles of 0.531 moles of sodium nitrite. That's what we are going to get. So thereafter, next we have to get the RFM of sodium nitrite because we want to get the mass of sodium nitrite, and mass is given by moles times RFM. So we have the moles of sodium nitrite, so we have to get RFM of sodium nitrite. So the RM of sodium is 23 plus, the one for nitrogen is 14 plus, we have 16 for oxygen times 2. When we put all this, we are going to get 69 as our RFM. So mass of sodium nitrite, that will be the next step. This will be given by moles multiplied by RFM of sodium nitrite. So the moles is 0.531 multiplied by 69, which is the RFM of that sodium nitrite. If we put this one in the calculator, we are going to get 36.639 grams. 69 grams of sodium nitrite. So if we have the number of moles, I mean the mass of that sodium nitrite, so what was the initial mass given? It was 53.0 grams. If you check, 53.0 grams of sodium nitrite was dissolved up to 600 centimeter cube of distilled water. So this mass that we have gotten, that 6.639 grams of sodium nitrite, was the mass of the sodium nitrite that reacted with the potassium manganese 7 solution. So we can have the percentage purity can be gotten by mass of the sodium nitrite reacted with the potassium manganese 7 divided by the original or the initial mass. The initial mass of sodium nitrite, then multiplied by 100%. That will be the formula that we are going to look to get the percentage purity of sodium nitrite. So here we are going to say that 6.639, which is the mass of the sodium nitrite that reacted with potassium manganese 7, divided by the original mass or the initial mass, which was 53.0 gram, multiplied by 100%. Here we are going to get 69.13%. So this will be the percentage purity of sodium nitrite. That's how we're going to do in question 1 of our lesson today. So next, let's proceed to the fourth aim of redox titration, that's determining the mole ratio. Example 1. We are told 25 centimeter cube of acidified iron 2 sulfate containing 6.28 grams in 250 centimeter cube solution completely reacted with 24 centimeter cube of 0.02 molar potassium manganese 7. Determine the number of moles of iron 2 ions that reacted with 1 mole of manganese 7 ions. The RFM of iron 2 sulfate is 278. So this is the RFM of hydrated iron 2 sulfate. Okay, the first step, we have to go and get the number of moles of potassium manganese 7 because we have the molarity and it is volume. So we can say moles of potassium manganese 7. So moles is given by molarity, which is 0.02, multiplied by volume, which is 24, then divided by 1000. Here we are going to get 0.00048 moles of potassium manganese 7. This will be the number of moles of potassium manganese 7. So let's go and get now the concentration side, the concentration of iron 2 sulfate. Remember here we are given 6.28 grams in 250 centimeter cube. So we have the RFM of the hydrated iron 2 sulfate. So we have to put this one, the concentration in grams per liter, so that we divide by the RFM so that we get the molarity of iron 2 sulfate. So we can say if 6.28 grams of this iron 2 sulfate was dissolved in 250 centimeter cube of distilled water, what about 1000 centimeter cube of distilled water solution? What mass of iron 2 sulfate are we going to get? So we say 6.28 gram multiplied by 1000, then divided by 250. So here we are going to get 25.12 grams per liter of iron 2 sulfate. That will be the concentration of iron 2 sulfate in grams per liter. So we can get the molarity of iron 2 sulfate because we have concentration in gram per liter and the RFM of iron 2 sulfate is given in the bracket. So we can say molarity molarity of iron 2 sulfate. Molarity is given by concentration of iron 2 sulfate in grams per liter over the RFM of iron 2 sulfate. So here concentration we have 25.12 grams per liter divided by the RFM, which we have 278. So here we are going to get 0.09 mole of iron 2 sulfate. That will be the molarity of iron 2 sulfate. Next, we are required to get the number of moles of iron 2 sulfate, because we have gotten the molarity and the volume is given in the question. So let's check. We check the first step. We are told 25 centimeter cube of acidified iron 2 sulfate. So we have the volume. So that means moles of iron 2 sulfate is given by molarity, which we have gotten now 0.09 multiplied by the volume, which is 25, and divided by 1000. So here divided by 1000, sorry. So here we are going to get 0.00225 moles of iron 2 sulfate. That's what we are going to get. So if we check, we have gotten the number of moles of iron 2 sulfate. So the question was determining the number of moles of iron 2 ions that reacted with 1 mole of manganese 7 ions. So the way you can see, this number of moles of iron 2 sulfate has reacted with the 0.00048 moles of potassium manganese 7. So we can ask, what about 1 mole of potassium manganese 7? So what we can say is 0.00048 moles of manganese 7 ions in potassium manganese 7 solution has reacted with 0.00225 moles of iron 2 ions in iron 2 sulfate. So what about 1 mole? Because we are told with 1 mole of manganese 7 ions. So what about 1 mole? So we are going to say cross multiply. So we are going to have 1 mole times 0.00225 divided by 0.00048. Here we are going to get roughly 5, because we get 4 point something, 4.8 something, 4.9. If we round off, we get 5. So what does this mean? This means the mole ratio. So we are going to say hence the mole ratio of manganese 7 ions ratio iron 2 ions is 1:5. That's what it means. So that's how we are going to calculate the aim of redox titration, that's determining the mole ratio in example 1. So we go to example 2. So in example 2, we are told you are provided with solutions B and Q. Solution B is 0.02 molar acidified potassium manganese 7 solution. Solution Q was prepared by dissolving 4.18 gram of solid Q in distilled water to make 250 centimeter cube of solution. You are required to determine the number of moles of Q that reacted with 1 mole of potassium manganese 7, or with 1 mole of solution B. Okay, the procedure for this practical or this titration, we are to place solution B in a burette by bed 25 centimeter cube of solution Q into a 250 centimeter cube conical flask. Then we are asked to titrate solution Q with solution B until a permanent pink color just appears. Record your results in the table below. Repeat the above procedure 2 more times and to fill the table. Okay, the first titration, second and third. The final burette reading in centimeter cube, the initial burette reading in centimeter cube, and we have also the volume of solution B used in centimeter cube. So this table has been filled for us, and this is the volume of solution B used. The first titration we are having 14.9, second titration 15.0, third titration 15.1. So let's go to the first question, part A. We are to calculate the average volume of solution B used. Average volume. So how are we going to get average volume? Average volume. So average volume of this solution B used, we have to check first of all the titers or titrants. Here we have 14.9, 15.0, 15.1. So the range of all this is plus or minus 0.2. So all of them can be added and divided by the number of trials or the number of titrations. So we're going to say 14.9 for the first titration, 15.0 plus the third one 15.1. So divided by the 3 attempts. So this one will give us 15.0 centimeter cube. 15.0 centimeter cube. That's how we are going to calculate the average volume of solution B used. So part B. So part B, we are to calculate the moles of potassium manganese 7 used. So check, we have gotten now the average volume of solution B as 15 centimeter cube. So if we check, we are asked to calculate the number of moles of potassium manganese 7. Which was potassium manganese 7? It was solution B, and we have the molarity as 0.02 mole. So that means we can get the number of moles of potassium manganese 7 used. So moles is given by moles of potassium manganese 7. Moles is given by molarity, which is 0.02 multiplied by volume, which is 15.0, and divided by 1000. So what are we going to get here? We are going to get 0.0003 moles of potassium manganese 7. Okay, next we are told part C, calculate the concentration of solution Q in moles per liter. So they have given us the concentration of solution Q in the information. You are provided with solution Q, or solution Q was prepared by dissolving 4.18 grams of solid Q in distilled water to make 250 centimeter cube. So that's the information given. So we can start there and say 4.18 grams of solution Q was dissolved in 250 centimeter cube of solution. What about 1000 centimeter cube of solution? What are we going to get? We cross multiply. There we are going to have 4.18 multiplied by 1000, then divided by 250. So here we are going to get 16.72 gram per liter. That will be the concentration in gram per liter. So next we can look for the molarity. Remember, molarity is given by concentration in gram per liter over the RFM. Molarity equal to concentration in grams per liter or per centimeter cube divided by RFM. So here we have gotten 16.72 as our concentration in gram per liter divided by the RFM of Q. The RFM of Q is 278. So here the molarity that we are going to get will be 0.06 mole. That will be our molarity. So we have calculated part B. So next, part C. So in part C we are told, part D we are told determine the number of moles of Q, Roman 1, in 25 centimeter cube of solution. Remember, we have gotten in part C the molarity. We have gotten the molarity of solution Q to be 0.06 mole. So we can get the number of moles of Q because we know moles of Q. Moles is given by molarity, which we have gotten 0.06 multiplied by volume, which is 25.0, then we divide by 1000. So here we are going to get 0.0015 moles of solution Q. Moles of solution Q. That will be the number of moles of solution Q in 25 centimeter cube of solution. So Roman 2, we are told determine the number of moles of Q which react with 1 mole of potassium manganese 7. So we are having here the number of moles of potassium manganese 7 solution. It was 0.0003 moles of potassium manganese 7. So we are saying 0.0003 0.0003 moles of potassium manganese 7 reacted with this number of moles of solution Q, 0.0015 moles of solution Q. So we can say, what about 1 mole? What about 1 mole of potassium manganese 7? Because we are told determining the number of moles of Q which react with 1 mole of potassium manganese. What about 1 mole? That's what we are saying. So we cross multiply. So what are we going to get? We are going to say 1 times 0.0015 then divided by 0.0003. So we are going to get 5. So we can conclude. So what does that mean? The mole ratio. You can say the mole ratio between, you can say hence the mole ratio of potassium manganese 7 ratio solution Q is 1:5. That's what we're going to conclude. So next we are going to go to Roman E. That's the 5th aim of redox titration, and that's determining the amount of water of crystallization. Example, we are told 30 centimeter cube of 0.02 molar potassium manganese 7 solution was required to completely oxidize a 25 centimeter cube solution containing 47.04 gram per decimeter cube of ammonium iron 2 sulfate, which is a double salt, and it has this formula. We are told determine the value of X in ammonium iron 2 sulfate using the ionic question below. So we can start by looking the number of moles of potassium manganese 7 because we have its molarity and also volume. So you can say moles of potassium manganese 7 is given by molarity, which is 0.02 multiplied by volume, which is 30, then we divide by 1000. So here we are going to get 0.0006 moles of potassium manganese 7. So next we have to get the number of moles of ammonium iron 2 sulfate using the ionic equation given. So manganese 7 ions ratio iron 2 ions is 1:5. 1:5. So we have gotten the number of moles of manganese 7 ions in potassium manganese 7 as 0.0006. What about the one for iron 2 ion? So we are going to cross multiply, say 0.0006 multiplied by 5 and divided by, here we are going to get 0.003 moles of iron 2 ion in ammonium iron 2 sulfate. So like that. So the next step, we have to get the molarity. We have to get the molarity of ammonium iron 2 sulfate. How are we going to get? Remember, we have gotten the moles. We can multiply it by 1000 divided by the volume. The volume is 25. We're having 25 centimeter cube there. So we're going to say molarity will be equal to moles, which is 0.003 multiplied by 1000, then divided by volume, which is 25. So what are we going to get there? So we are going to get 0.12 mole as our molarity. So thereafter we are going to get next RFM, the RFM of ammonium iron 2 sulfate. Ammonium iron 2 sulfate. So how do we get RFM? RFM is given by concentration in grams per liter divided by molarity. So what we have here is 47.04 grams per decimeter cube. That's already concentration in grams per liter, 47.04, divided by the molarity, which we have gotten 0.12. So here we are going to get 392 as our RFM. Yeah. So next, if we have the RFM, next we have to get the value of X. So how are we going to get the value of X? First of all, we have to know how to write that ammonium iron 2 sulfate, the way it is written. So we're going to say the formula there, NH4 in bracket 2 sulfate dot iron 2 sulfate dot, we have X mole of water of crystallization. All of this will be equal to 392. So check very well. So we have to say 2 in bracket 14 for nitrogen, 1 times 4 for hydrogen, plus sulfur for 32, plus 16 times 4, plus. So I'm having iron, which is 56, plus sulfur 32, plus 16 times 4 for oxygen, plus. So I'm having X in bracket 1 times 2 for hydrogen, plus 16 for oxygen, close bracket. All of this will be equal to 392. That's what we're going to have. So we are going to get 284 by putting all these values in the calculator, plus here we are going to get 18x will be equal to 392. So we have to collect the like times. 18x will be equal to 392 minus 284. So that means 18x will be equal to 108. So divided by 18, divided by 18, x will be equal to 6. That's what we are going to get. So the value of x was 6. So if you could have been told to write the formula of the double salt, we could have put 6 on the side of the water of crystallization. That is the end of our lesson today. Thank you.